Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Assalamu alaikum. Today we will cover GRE Physics 1777, question 4, Electricity and Magnetism Circuits. Theoretical background series circuit. In a series connection, if an amount of charge Q exits resistor R1, charge Q must also enter resistor R2, otherwise charge will accumulate on the wire between the resistor. The potential difference applied across series combination of resistor divides between the resistor. Therefore, the current in the series circuit remains the same. The voltage drop across resistor R1 is delta V1. The voltage drop across resistor R2 is delta V2. Greater the resistance, greater the voltage drop. Total voltage drop is equal to delta V1 plus delta V2, and the equivalent resistance is R1 plus R2. Total voltage drop across the circuit is equal to delta V1 plus delta V2. Delta V1 is the voltage drop across resistor R1. Delta V2 is the voltage drop across resistor R2. Greater the resistance, greater the voltage drop. Therefore, delta V1 is equal to IR1. Delta V2 is equal to IR2. Total voltage drop delta V is equal to IR equivalent, where R equivalent is the total resistance. Therefore, IR equivalent is equal to IR1 plus IR2. Since the current in the series circuit is same, we get R equivalent is equal to R1 plus R2. Let's start with the simplest possible case. A 20-volt battery is connected to two 10-ohm resistor in series. R equivalent is equal to R1 plus R2. It is equal to 10 ohm plus 10 ohm, giving us equivalent resistance of 20 ohm. Delta V, the total voltage change across the circuit, is equal to IR equivalent. 20 volt is equal to I into 20 ohm, giving us the current of 1 ampere. Delta V1 is equal to IR1 is equal to 1 ampere into 10 ohm, giving us delta V1 is equal to 10 volt. Delta V2 is equal to IR2 is equal to 1 ampere into 10 ohm, giving us delta V2 is equal to 10 volt. Therefore, there is a 10 volt voltage drop across one 10 ohm resistor and a 10 volt voltage drop across the other 10 ohm resistor. Let's extend the problem further. A 12 volt battery is connected to resistor R1 that is equal to 1 ohm, R2 that is equal to 2 ohm, R3 that is equal to 3 ohm in series. Therefore, R equivalent is equal to R1 plus R2 plus R3. This is equal to 1 plus 2 plus 3. Therefore, equivalent resistance is equal to 6 ohm. Delta V, the voltage drop across the circuit, is equal to I, R equivalent. Delta V is equal to 12 volt, R equivalent is equal to 6 ohm, giving us the current of 2 ampere. Delta V1, the voltage drop across resistor R1 is equal to IR1. This is equal to 2 ampere multiplied by 1 ohm, giving us delta V1 to be 2 volt. Delta V2, the voltage drop across resistor R2 is equal to IR2. This is equal to 2 ampere multiplied by 2 ohm, giving us delta V2 to be 4 volt. Delta V3 is the voltage drop across resistor R3 is equal to 2 ampere multiplied by 3 ohm, giving us delta V3 to be 6 volt. Delta V is equal to delta V1 plus delta V2 plus delta V3 is equal to 2 plus 4 plus 6, which is equal to 12 volt. The current in the series circuit remains the same. Since the charge cannot build up in the wire between the resistors, the greater the resistance, the greater the voltage drop. The total voltage drop is equal to the sum of voltage drop across each resistor. Now let's consider parallel circuits. Notice both resistors are connected to the terminal of the battery. Therefore, potential difference across the resistor is the same. A junction is any such point in the circuit where the current can split. The split results in less current in each individual resistor than the current leaving the battery. Since charge is conserved, I is equal to I1 plus I2. I is the total current and is equal to V over R equivalent. I1 is the current in resistor R1 and is equal to V over R1. I2 is the current in resistor R2 and is equal to V over R2. Since the potential difference across the parallel circuit is the same, we get 1 over R equivalent is equal to 1 over R1 plus 1 over R2. This means 1 over R equivalent is equal to R1 plus R2 divided by R1 R2. If we cross multiply, R equivalent is equal to R1 multiplied by R2 divided by R1 plus R2. Let's start with a simple example. A 4-volt battery is connected to two 2-ohm resistors in parallel. Equivalent resistance in parallel is equal to R1 into R2 divided by R1 plus R2. This is equal to 2 multiplied by 2 divided by 2 plus 2, giving us the equivalent resistance of 1 ohm. Equivalent resistance in parallel is less than the resistance of R1 or R2. Delta V is equal to I R equivalent. Delta V is equal to 4 volt. R equivalent is equal to 1 ohm. This gives I, the total current, to be equal to 4 ampere. I1 is equal to delta V over R1. This is equal to 4 volt divided by 2 ohm, giving us I1, the total current in resistor 1, to be equal to 2 ampere. I2 is equal to delta V over R2. This is equal to 4 volt divided by 2 ohm, giving us the current in resistor 2 to be equal to 2 ampere. I is equal to I1 plus I2. This is equal to 2 ampere plus 2 ampere, which gives the total current of 4 ampere. This means 4 ampere current splits into I1 and I2, that is equal to 2 ampere each across each 2 ohm resistor. Let's consider another example. A 12-volt battery is connected to resistor R1, that is equal to 2 ohm, and resistor R2, that is equal to 4 ohm in parallel. R equivalent is equal to R1 into R2 divided by R1 plus R2. This is equal to 2 multiplied by 4 divided by 2 plus 4, giving us the equivalent resistance of 8 over 6. Delta V, the potential difference, is equal to I, that is the total current, into R equivalent. This is equal to 12 volt into I into 8 over 6. This gives a total current of 9 amperes. Delta V is equal to I1 R1. Delta V is equal to 12 volt. R1 is equal to 2 ohm. I1, the current through resistor R1, is equal to 6 ampere. Delta V is equal to I2 R2. Delta V is equal to 12 volt. R2 is equal to 4 ohm. I2, the current through resistor R2, is equal to 3 ampere. Total current is equal to I1 plus I2. This is equal to 6 ampere plus 3 ampere, which is equal to 9 ampere. A point to note over here is that the resistance of R1 is less than the resistance of R2. Therefore, the current in I1 is greater than the current in I2. Let's consider another example. A 12-volt battery is connected to three resistors in parallel. R1 is equal to 2 ohm, R2 is equal to 3 ohm, R3 is equal to 4 ohm. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is equal to 1 over 2 plus 1 over 3 plus 1 over 4. This gives R equivalent is equal to 12 over 13 ohm. Delta V is equal to I R equivalent. Delta V is the potential difference and is equal to 12 volt. R equivalent is equal to 12 over 13. Therefore, total current I is equal to 13 amperes. Delta V is equal to I1 R1. I1 is equal to delta V over R1. Delta V is equal to 12 volt. Resistance R1 is equal to 2 ohm. Current in resistor R1 is equal to 6 amperes. Delta V is equal to I2 R2. I2 is equal to delta V over R2. Delta V is equal to 12 volt. R2 is equal to 3 ohm, giving us the current in resistor 2 to be equal to 4 ampere. I3 is equal to delta V over R3. Delta V is equal to 12 volt. R3 is equal to 4 ohm, giving us the current in resistor 3 to be equal to 3 ampere. I is equal to I1 plus I2 plus I3. This is equal to 6 ampere plus 4 ampere plus 3 ampere is equal to 13 amperes. Notice resistor 1 has a resistance of 2 ohm and a current of 6 ampere. Resistor 2 has a resistance of 3 ohm and current of 4 ampere. Resistor 3 has a resistance of 4 ohm and current of 3 ampere. Therefore, as the resistance increases, the current in that branch decreases. Now let's come to our main objective, that was question 4 of GRE 1777. For the circuit shown in the figure, what is the current I through the 2 ohm resistor? A 2 ampere, B 4 ampere, C 5 ampere, D 10 ampere, E 20 amperes. The first thing that we need to do is to find the resistance of the entire circuit. There are two resistors in parallel, R2 that is equal to 1 ohm and R3 that is equal to 2 ohm. Therefore, we can use the formula R parallel is equal to R2 into R3 divided by R2 plus R3. This is equal to 2 over 3 ohm. Equivalent resistance is equal to R1 plus R parallel, that is equal to 1 plus 2 over 3, that is equal to 5 over 3 ohm. Delta V is equal to I R equivalent. I is equal to delta V over R equivalent. Delta V is equal to 20 volt. R equivalent is equal to 5 over 3. Therefore, total current is equal to 12 ampere. Delta V1 is equal to IR1, that is equal to 12 ampere multiplied by 1 ohm. Therefore, delta V1 is equal to 12 volt. Therefore, the current in resistor R1 is equal to 12 ampere and the voltage drop across resistor R1 is equal to 12 volt. As you can see in the diagram, the current I will split into I2 and small I. Delta V2 is the voltage across resistor R2 and R3 and it is equal to 20 minus 12 volt, that is equal to 8 volt. Delta V, total voltage drop, is equal to delta V1 plus delta V2. Delta V is equal to 20 volt, delta V1 is equal to 12 volt. Therefore, delta V2 is equal to 8 volt. Delta V2 is equal to I2 R2. Delta V2 is equal to 8 volt. R2 is equal to 1 ohm. Therefore, I2 is equal to 8 ampere. Delta V2 is equal to small I R3. Delta V2 is equal to 8 volt. R3 is equal to 2 ohm. Therefore, small I is equal to 4 amperes and this is what we needed to find. We can recheck our answers easily. I is equal to I2 plus small I. This is equal to 8 ampere plus 4 ampere. Therefore, I is equal to 12 amperes. That is correct. Delta V is equal to delta V1 plus delta V2. Delta V1 is equal to 12 volt. Delta V2 is equal to 8 volt. This gives total voltage drop to be 20 volt, which is again correct. D is the correct answer. Small I is equal to 4 ampere. 64% people got this correct. May Allah bless us all. Thank you for watching. Allah Hafiz.